Today we are looking at 12.1, radian measure, arc, sectors, and segments. So you may or may not have seen some of the stuff in here. I think you will have seen some of it. So students will be able to convert angles from degrees to radians and radians to degrees. And students will be able to find the length of an arc in the area of a sector. Who cares? Sine waves are the building blocks of sound. In fact, all sounds can be created by combining sine waves. Sound travels as a transverse wave. Musical instruments and electronic tools use these waves to produce sounds of different frequencies, volume, and pitch. Many phenomena that have a periodic or repeating pattern, such as tides, sunlight, and Ferris wheels, may be modeled with trigonometric functions. All right, a radian is the measure of an angle with its vertex at the center of the circle between two radii with endpoints that are one radius length apart on the circumference of the circle. So let's draw a picture here, and let me highlight this, okay? So what I'm saying is this arc has a length of the radius, okay? So then this angle theta, if theta is the angle that intercepts an arc length equal to the radius, that is the definition of 1 radian. Well, it takes 2 pi radians. Remember, circumference was 2 pi r. And if I let r be 1, then the circumference, the distance around a circle, is 2 pi. We also know the distance around a circle is 360 degrees. So if I divide by 2, then what I know is pi radians is equal to 180 degrees. So that's important. So pi is 180. What would pi over 2 be? Well, pi over 2 would be 90 degrees. What's pi over 3? Well, pi over 3 would be 60, because remember, pi is 180. Then what is pi over 4? It's 45 degrees. And the last one, what is pi over 6? It's 30 degrees. All right, so converting between degrees to radians, you take the degrees and multiply by pi over 180. And if you want to find the degrees from radians, you multiply by 180 over pi. So in example 1a, it says convert 120 degrees to radians. And what helps me is I want radians to be my answer. So pi is radians, so it's in the top. And then notice the degree symbols cancel because one's in the numerator, one's in the denominator. All right, what do you get for 120 degrees? Well, you should get 2 pi over 3. Because 60 goes into 120 twice, 60 goes into 180 3 times. All right, what if you want to convert 4 pi over 3 to degrees? Well, I want the degrees in the top. Work it out. Tell me what you get in degrees. Well, the pi's cancel. 3 goes into 180 60 times, so 4 times 60 is 240 degrees. All right, an arc is part of the circumference of a circle. Minor arc, AB, is the shortest distance between point A and B on the circumference of a circle. So let's draw a circle here. So if this is my center, we'll call the center O. Let's call this A and B. So minor arc AB is the shortest distance. Now, if I wanted a major arc, now I'm going to need another letter. So this is a minor arc. If you want a major arc, you need 3 letters. So I would say arc ACB. A major arc is more than 180. A sector is the region enclosed by 2 radii and an arc. Unless otherwise indicated in a question, we assume sector AOC would, and I don't know why I have a C there, AO, let me change it. Let me draw another one. Then this one goes here. Then we would say it's going to be the minor sector unless otherwise indicated. A chord is a line segment joining 2 points on the circumference of a circle. So I could have a chord, it's a line segment, okay? So AC would be a chord. A segment is the region between a chord and the arc. So it's here. The length of an arc is given by L equals R theta, and the area of a sector is 1/2 R squared theta, where theta is measured in radians. Okay, that's going to be important. So in this example, it says find the arc length. Well, the arc length, and I'm going to use capital L just so I don't think I'm making a 1, would be the radius. So my radius is 8. My theta is in radians. So you can do this if this would be on the non-calculator part of your IB exam. That would be 6 pi, and this looks like centimeters. Or if it's on the calculator part, that's 18.8 centimeters. The area of the sector, we're going to use 1/2 R squared theta. So it's 1/2 8 squared times 3 pi over 4. So I get 24 pi, or now you should use the approximately equal to symbol. This is centimeters squared, catching myself here. And that's 75.4 centimeters squared. All right, then let's look at example 3. This is where they get really fun, okay? This is very fun. It says find the shaded area. Well, what do you think we might do to figure that out? Okay, well, here's the deal. I could find the area of sector AOB, and then I can subtract the area of triangle AOB. Do you see what I'm saying here? I could find the area of the triangle. Okay, here's my triangle. And then I could find the area of the sector, and then if I subtract, that'll give me this, it's actually the segment, isn't it? Okay, so my area of my sector is going to be 1/2 R squared theta minus, now this is not a right triangle, okay, so it's going to be 1/2, now be careful, this is 6, so I'll do 6 times the sine. Oh, remember this formula from the last chapter? Woo! Okay, here we go. So this is going to go 1/2 r squared times 2 pi over 3. Half of 36 is 18. I'm going to use my unit circle ability, and that sign of 2 pi over 3 is radical 3 over 2. All right, half of 36 is 18 times 2 pi over 3. 6. That's 12 pi minus 9 square root 3. So this would be my exact answer, or 22.1 centimeters squared. Depends on, which part we have. Oh, that was a really great problem. Okay? All right, that wraps up the notes.